In this example, we'll look at how to solve an application problem that's going to require solving a quadratic, or using a quadratic expression. We're going to start by looking at the formula that we're given and filling in what we know. So here's the problem. At the end of 2 years, P dollars invested in an interest rate of R compounded annually increases to an amount A given by the following formula. A equals P times the quantity of 1 plus R quantity squared. We want to find the interest rate when we know that the principal is $192 and the amount in the account is $363 in 2 years. It's interesting to note, by the way, you want to read this carefully, that this formula that we're given is a formula that's already accounting for 2 years. And our problem is saying to do this for 2 years. So that's that's one thing that makes this problem a little bit unique from other problems that we'll often see. So we're going to start by writing the formula, and I know it's written right there in front of you, but if you've struggled at all with this type of problem, then this process of writing out the formula and then writing what's given and then making note of what it is that we're trying to find might be really beneficial. So to start with, I can see that we're given that the $192 is increased. So I know that the 192 is going to be the principal. That's part of this is just from experience of reading these problems. You want to understand that principal, P, is the amount invested. And so this 192 is what is invested. Now A is the amount that we have the end of the term. So an amount A, dollars. So we're going to read this to interpret that the A, the amount, is $363. We don't have to bother about the 2 years because this formula already takes into account the 2 years. But what is it that we're trying to find? Find the interest rate. And so that's where we'll know, and I often do that by just drawing a box around it. That's where we know this is what we're looking for. So to solve this problem, I'm going to go to the formula, and in place of A, I'll write the 663. So we have 363 equals, and in place of P, I'm going to write 192. And then we have times the quantity of 1 plus the interest rate, quantity squared. So all I've done is copied the formula. A equals principal times the quantity of 1 plus the interest rate, quantity squared. If I want to solve for the rate, then what I want to do is isolate this expression that includes the rate. So I'm going to isolate that by dividing both sides by 192. Well, actually, I'm going to isolate the 1 plus R quantity squared by dividing by the 192. But because I'm dividing the right side by 192, I'm going to also need to divide the left side by 192. So the 192 over 192 leaves us the 1 plus the rate squared. And then I could try this on a calculator to see if this gives me anything simplified. 363 divided by 192. You never know, it might work out. It doesn't, so I'm going to leave it 363 out of 192. Because when I divided 163 divided by 192, I didn't get anything easier. You know, though, I do think that it'll reduce. It reduces by maybe by 3. If I divide 363 by 3, I get 121. If I divide 192 by 3, I get 64. So I could reduce this a little bit. All I've done is a simple reducing the fraction. Do you see what's next to solve for a radical equation? What's next? I'm sorry, not radical. I'm giving the answer away. To solve this quadratic equation, I'm going to use the square root property and take the square root of both sides. But when I use that, I have to be mindful of saying that it's the positive or negative value of the square root. So I'm going to take the square root of both sides, and on the left side, the square root of 121 is 11, square root of 64 is 8, and then the square root of this square, those undo each other. So the square root of this quantity squared is just the 1 plus r. Let me walk you through that a little bit more just to make sure you follow what we're doing here. When I do the square root of a square, I'm left with just this piece that was inside, because this square and this square root will undo each other. So when the square and square root undo each other, they disappear, we're left with the 1 plus r. And now to solve for r, I'm going to subtract 1 from both sides. So it looks like we get the rate equals -1 plus 11/8 or -1 minus 11/8. When I look at this -1 minus -8, I know I'm going to get a negative response there, a negative answer. So I know that the rate can't be negative, so that must be an extraneous solution, a solution that doesn't make sense for our problem. But when I do 11/8 minus 1, that's 11/8 minus 8/8, I get 4/8 or 1/2. Oh wait, I'm sorry. 8, 9, 3/8, right? Went to look at that and I saw something just wasn't quite right. So when I think back to the math, if I do 11/8 minus 8/8, that's actually 3/8, right? And if I do 3/8 as a decimal, 3 divided by 8 is 0.375. And by the way, I could have used my calculator with the 11 fraction 8 minus 1 to get that 3/8. And then when I do that division, it's 0.375. So this rate should be a percent. So to change this 0.375 to a percent, I'm going to multiply it by 100, or simply move that decimal 2 to the right to get 37.5%. So it looks like the interest rate is 37.5 or 37.5%. Well, I hope that helps you with this type of problem. If you do need further assistance with this, please don't hesitate to reach out to me. Notice that when I took the square root of both sides here, this seems to be one of the most common mistakes. When I did the square root of both sides here, notice that I have to think of it as being a positive or negative square root of 121 over 64. But you might have not done that. You might have just done the square root of 121 over 64, and this extraneous solution would have never come up. You would have still gotten the right answer. But I want to call it to your attention and make sure you're still doing that correctly each time, in the case you get to one of those problems where that negative response does in fact work for the equation. Let me know if you need further help with this, and thanks so much for the work you're doing.